Greetings from Jim AG6IF. I want to show you a couple things today. First of all, I'm building a mag loop for 10 meters tuned with a air variable capacitor. And if you ever played around with those, what's interesting is they're super sensitive to turning that capacitor and get it tuned. My option here, my goal here was to tune it for the JT65 10 meter frequency, which is 28076, 28.076. If you think back to your sideband and classes and band classes and stuff, the range on 28076 goes from 0 hertz of audio up to about 1500 or whatever, the passband. Most people operate between 500 hertz and maybe up into 2000, maybe even 2500. So that adds on to 28076. So basically, the sweep of an antenna, there's 2 points of resonance on this one. There's one right here where it crosses the center line, and there's one right here where it crosses back over the center line. One side is inductive, one side is capacitive. And then the red line here is SWR. So what I want to show you, instead of, I want to show you a technique to fine-tune the antenna, because in my case I haven't built my Arduino, I haven't hooked my Arduino stepper motor up there yet. So it doesn't take much, and it moves a long ways when you turn the capacitor. It's very, very sensitive. So once you get it close, you got to kind of decide. So 28076 is the dial frequency for JT65. But then we want to operate maybe between 500 hertz and my GPS is talking for some reason. I'm not sure why. That's funny. So you got to decide where you're going to tune the antenna, because you only get one spot, and you're operating in a fairly wide, even with JT65, depending on where you select the cursor on the scale there, you're operating a good 1000 hertz around here and there. So what I want to do is I want to move the resonance of this antenna. It's at 28079 right here. I want to make it a little bit higher because I usually operate in the middle to the upper part of the band. So instead of turning the capacitor and it moves back and forth, I'm going to show you a technique if this works. We're going to move the bottom of the antenna slightly. If I slide it to the right, I'm going to show you how this works, but the graph moves to the right. If I slide it to the left, the graph moves to the left. And I've affixed the antenna to a 3/4 inch PVC pipe with a zip tie holding the bottom of it. So I'm going to go slide it a little bit to the right. Hopefully when I get outside here you're going to see this. So I'm going to walk outside to my antenna and try to get that on the film here, on the picture for you. So here we go. We're going to be on our feet. Out of the shack, through the garage. And let's see if we can get out here, if the camera will hold up in this light. I'll show you the antenna. It's right here. That capacitor has a 20 to 120. Okay, here's what I'm talking about. See my zip tie? I'm going to slide the antenna a little bit to the right, just a smidge. Okay, and let's go back and re-sweep it on the analyzer and see what happened. It should move that whole graph assembly to the right. That's the goal anyway. Back into the shack. Sorry about all the motion here. Get the camera plugged back in. Alright, we made it. Now we're back. I'm going to hit the R button for re-sweep. It's going to leave the old one there. And we're going to watch and see what happens. Hopefully this whole assembly moves to the right. Here we go. And there it goes, moving to the right. Isn't that cool? Now, if you move the capacitor instead, a very subtle movement where you can't even see it move, you have to kind of use the force. It moves a long ways. It'll move completely out of this picture. So I need to get a stepper motor hooked up to that. So anyway, let's see where we're at now. We've got a resonant point at 28085 and another one over here on this side. And this is our SWR. I'm going to re-sweep the graph here, so it'll clear it and redo it so it's easier to spot what I'm talking about. Here we go. S. I'm using an AIM 4170, and I'm plotting the SWR and the resonance, capacitance, and inductive nature of the antenna. All right, so we're going to be interested in this side right here. This is the resonance point. This is the SWR. If I position the cursor properly, you can see that my SWR right there is 1.397 to 1, and it's resonant at 28086. So that's about 1,000 hertz on the JT65 waterfall. 1,000 hertz. That's right in the middle of the band. So if I go higher, it's going to move up this way, and SWR will go up to maybe 1.7. Obviously, the resonance point is only right where it crosses. Right where it crosses is the only spot that antenna is resonant, right there, and it's very narrow. So you have to pick. So if you're operating 1,000 hertz wide, and it's going from here to here, it's only resonance at one little spot in there. So there's 2 points here. Capacitance, antenna has extra capacitance, extra inductance. Right at where it crosses is the only place it's truly resonant. And again, this is SWR. So our SWR is 1.25 between that point and that point. And that's from 28077 to 28083. So that's exactly where I want it. And you saw how I achieved that by sliding the bottom of the antenna. In a mag loop antenna, the capacitor and the feed need to be 180 degrees apart. By altering that ratio just a tiny little bit, and you saw me slide the bottom of the antenna over just a little bit, maybe 1/8 of an inch, that adjusts that feed point relationship and actually changes the resonance of the antenna, which I discovered more or less by accident, because I had the antenna had went askew a little bit in its mounting, and the readings went crazy, and I was like, what is going on? Okay, now I can use that to my benefit, because think of it as a fine-tuned capacitor for your mag loop antenna. So this is a 10-meter mag loop. It tunes from, I've got 20 picofarads on that cap up to 120, and this antenna will work on 10 meters, 12 meters, 15, and 17. By extending the capacitor boundaries, you can extend the usefulness of the antenna. But I tried to make this one for my club frequency at 28360, and the extra stuff is good too. But anyway, thank you for watching. This is an AIM 4170 analyzer. It's a very nice tool, and without it, I don't know how anybody would even begin to do this kind of thing with the graph. And you can also plot a whole bunch of other things. You have to be a lot smarter than me to figure some of those out, but I'll tell you what, it's a very nice tool. If you're looking for an analyzer, make sure you check that one out. It's made by Array Solutions. It's not cheap either. It's a professional quality tool. It does require you hooked to a computer, but if you're playing with antennas and want to see really what's going on, this antenna, again, I'm just looking at 28 megahertz to 28.150, and I can open up those limits and so on. And the top is SWR 3.25. This is 2 right here, and again, my dip comes down to about 1.25 to 1. So my useful range of the antenna under 2.0 would be easily to see right here on the left would be about 28.063, and over here on the right 28.096 looks like. So this is a mag loop antenna. It's tuned with a air variable capacitor. It's 4 feet in circumference. It's made with 45-degree angle copper tubing, thin wall, 3/4 inch, and I'm feeding it with a small loop with a SO239 on it. You might have seen that in the earlier part there. And it's approximately 20% size of the antenna, the feed loop there. And I added a little bit more on this one just to get it to come in better. So I added another inch onto it. So that's the antenna. They're super fun to play with. I've got one for 30 meters. It's 12 feet in circumference, and I use that for APRS on robust packet on 10.147.300. So Anyway, thanks for watching Saturday morning in California playing with antennas. I appreciate everyone who checks these videos out, and I hope you get something out of them. And I'm sure enjoying ham radio. This is Jim AG6IF, always glad it's Friday with a 6 in the middle, saying 7-3. Thank you.